At this point in the progression, we're going to talk about subtracting 2 or 3 from numbers. So they'll be able to count back 2 or 3 within 5 and then count back 2 or 3 within 10. But it's really huge to develop that understanding at this point that we can either count back or we could also count up. We can think about it as a missing add-end problem because sometimes the numbers that we're given is more efficient to count up. So you'll see what I mean as we explore these again in our concrete, pictorial, and abstract ways. So first of all, another way I love to generate numbers is to have 10 frame dice. So you can roll 10 frame dice. So we have 7 and we have a 2. So I would want to do 7 and I would want to take away 2. Now at this point, we could use teddy bears or we could use any kind of concrete objects that you have, but I have some cubes here. So I would place out 7. So then I have 7 cubes. And I could put, again, as a story problem, I have 7 cookies and then I ate 2 of them. So if I have 7, and then I'm going to take away 2 and eat 2 of them, how many are left? So having that 7 and then counting back the 2, 7, 6, 5, would allow the students to get pretty efficiently to the know that there is 5 remaining. And again, of course, I can also then record that as an equation down here, draw a picture if I'd like to, even on the number path to show. But so 7 minus 2 will be showing it in that way. We got our concrete objects. Another way I love to generate numbers is to have dice in dice. So this is a 6 dice in dice. If you can see, there's a little dice inside there. That's also a 6-sided dice. So if I roll that, I also love to put these in like a felt covered bucket or something that has a soft bottom so that we're not having to listen to the shaking too much. Now the inside number is a 4 and the outside number is a 3. So I can do 4 minus 3. Students needing to know, of course, we start with a larger number and take away the smaller number. So now that we tell them we can't take away 4 from 3, because of course we can, we just get into negative numbers. I taught for many years in northern New Hampshire where our temperature went below 0. In fact, our recess cutoff temperature was 0. So students were very familiar with going below 0. But so if I have 4 minus 3, I can have my 4. Again, I love my smash it. So 4, and then I would do smash 3 of them, taking away 3. And I am left with 1. Now, here's an example also, though, that I'm beginning to see that, the 4 is made up of a 3 and a 1. So if I have the 4 and take away the 3, I am left with 1. It turns out that 3 plus the 1 also makes the 4. So I'm beginning to get that flexibility of thought that I could either be thinking addition to count up to the total, or I can be counting back and taking it away. So in first grade, we want to begin to move our students not always to always count back, but to understanding subtraction as a missing add-end problem. It can be much more efficient sometimes. Now, they also make dice in dice that are 10-sided. So as we're in first grade and working on our fluency within 10, this is another wonderful way of generating 2 numbers. So here I have an example of a 1 minus a 0 and being able to act that out, that it's a 1. I'm taking away nothing. So it still remains, leaving that 1 and articulating the generalization of taking away 1, taking away 0. You're taking away 1, it's the previous counting number, and taking away 0, it leaves the same amount. That sort of articulation of those properties are really important. So then we can move on to having the rec and rec. So if you have a rec and rec here, so again, we're going to be practicing these numbers within 10. Let's say I had an 8 and I wanted to take away a 6. Well, when I have students slide them over, they might begin by sliding over the beads 1 by 1 and counting up 8 of them and sliding them all over the other side. And that's totally developmentally appropriate. But I do want to move the kids forward a bit to realize that this is a benchmark of 5. So these blue ones here are 5. So I slide over 5. Then I can do 6 and 7 and 8, right, to get my 8 over there. And then other students who are ready for it, if they know 8 and 2 make a 10, I can slide 8 in one swipe without having to count these. I might be able to visualize, sabotage the 5 and the 3 and know that that's 8. But I also know that 8 and 2 make a 10, and I see the 2 there. So I know that must be 8 over here. So if I have my 8, and then of course I can be taking away amounts. So again, you can be sliding them back, or you can even be sliding them to the side and seeing what those 2 pairs of numbers end up being, and relating that to the addition problem as well. That 8 minus 3 leaves 5. Also means that 8 taking away 5 leaves the 3, and that the 5 plus the 3 makes the 8. So that fact family is important. You can visualize that there. With the Cuisenaire rods, we have here, I have, let's say, an example of 7. Oh, it's tough with the black on the black. Let me do a 10 rod so you can see that. So if I have a 10 rod and I am taking away 4 and I'm wondering how much is left. Oh, you're not going to see the dark green either. Hang on. Let's say we do the 10 rod and we're taking away 9. How many does that leave? But you can see here that if I were to start at 10 and to count back 9 of them, that is super inefficient. Instead, I want to think about, well, what can I add to the 9 to make the 10? That my pair of number of 1 and my 9 makes a 10. Here's where it's really crucial that we've worked on those decompositions of the numbers, because if I know that a 10 can get broken apart into a 1 and a 9, then if I have my 10 take away a 9, I'm left with the 1. 10 take away the 1, I'm left with my 9. And if I don't know that, I want the kids to have the understanding here at the within 10 to count up if the numbers are close together. So 10 minus 9 or 10 minus 8, 10 minus 7, I want them to think the addition. I don't want them counting back all that amount. We're not going to be able to count back these large numbers very efficiently. So here's an example also. I have the 8 rod here. So an 8, 6, and the 2. So of course we're seeing our fact families here as well, that 6 plus 2 makes the 8, that 8 minus the 2 is the 6, 8 minus the 6 is the 2, but also that we can see that the total amount, so like the 8 is equal to 6 plus 2, or 6 is equal to 8 minus 2. Being able to record that in that way and for students to be able to see that the answer on the left-hand side of the equal sign is super important, particularly in grade 1 as we introduce the idea of equality. Now remember, we want to think about the equal sign as being a relationship symbol. It is not an action symbol. If students are only used to thinking about taking away and then seeing an equal sign with an answer on the right-hand side, they think that the equal sign is an action. So that whenever they see it, they're going to be able to do some action, but that's not the case. We want things to be balanced. So let's say if I was doing this one again, let's say I have 8 and I am taking away 6. So I have a situation where it's 8 minus 6. So if I have 8 minus 6 equals question mark, I could be acting that out. I could be doing pictures. I want to do a picture here as well. So let's say that I did 8 circles. Now, I could be thinking about taking away 6, or I can think about how I have 6 and another amount that makes up the 8. So if I'm at 6, how many more do I need to get up to the 8? This is when we introduce the comparison word problem type in grade 1, where we have an amount. So I might give a story problem that says, like, I have 6 cupcakes and you have 8 cupcakes. How many more do I need to be the same as you? It encourages an additive thinking. This is based on the research of cognitively guided instruction by Thomas Carpenter and his colleagues. And so the idea is that we are thinking about an additive way, even though it involves finding a difference. But it's getting to that distance between the two numbers. So if I have 6, and how many more do I need to get up to the 8? Well, I need 2 more. So I know that my 8 minus my 6 is equal to the 2. But we also do want to be able to write that 2 is equal to 8 minus 6. That shouldn't look strange to the kiddos. They should be having lots of exposure, seeing it in that way. So lots of flexibility happening right here at the within 10. We got to make sure the students can think about adding up and counting back, because it'll be depending on the numbers that we're given, which method is most efficient, particularly as we get to higher numbers and double-digit numbers, triple-digit numbers, and even decimals and fractions down the road. Super, super powerful.